Welcome to this presentation. In this presentation, we are going to see about the media access control. In the previous models, we have discussed about data link control, a mechanism which provides a link with reliable communication. Now, we assume that there is an available dedicated link between the sender and the receiver. And this assumption may or may not be true. If we have a dedicated link when we connect to the internet using PPP as the data link control protocol, then the assumption is true and we do not need anything else. On the other hand, if we use our cellular phone to connect to another cellular phone, the channel, that is the band allocated to the vendor company, is not dedicated. A person a few feet away from us may be using the same channel to talk to her friend. So we can consider the data link layer as two sublayers. The upper sublayer, that is you can see, the upper sublayers is responsible for data link control and the lower sublayer is responsible for resolving access to the shared media. So if the channel is dedicated, we do not need the lower sublayer, that is multiple access resolution layer. And IEEE has actually made this division for LAN, that is data link layer is divided into two layers called data link control and multiple access resolution. The upper sublayer that is responsible for flow and control is called the logical link control, that is LLC layer, and the lower sublayer that is mostly responsible for multiple access resolution is called media access control layer. When nodes or stations are connected and use a common link called a multipoint or a broadcast link, we need a multiple access to protocol to coordinate access to the link. The problem of controlling the access to the medium is similar to the rules of speaking in an assembly. The procedures guarantee that the right to speak is upheld and ensure that two people do not speak at the same time and do not interrupt each other and do not monopolize the discussion, which is not actually done in assembly. So the situation is similar to multi-point networks. Many formal protocols have been devised to handle the access to a shared link. Now we categorize this into three groups, that is protocols belonging to each group is divided into random access, that is random access protocols, controlled access protocols, channelization protocols. Now let's move on to random access protocol. In random access or contention methods, no station is superior than another station and none is assigned the control over the other. No station permits and doesn't permit another station to send. At each instance, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send. The decision depends on the state of the medium, that is whether it is idle or busy. In other words, each station can transmit when it desires on the condition that it follows a predefined procedure, including the testing of the state of the medium. So two features give this method its name, that is random access. First one is there is no scheduled time for a station to transmit. Transmission is random among the stations. That's why these methods are called random access. Second, no rules specify which station should send next. Stations compete with one another to access the medium. That's why these methods are also called contention methods. So in random access method, each station has the right to the medium without being controlled by any other station. However, if more than one station tries to send, there is an access conflict, that is collision, and the frames will be either destroyed or modified. To avoid access conflict or to resolve it, when it happens, each station follows a procedure that answers some of the questions like, for example, when can the station access the medium? What can the station do if the medium is busy? How can the station determine the success or failure of the transmission? What can the station do if there is an access conflict? The random access methods have evolved from a very interesting protocol called Aloha, which used a very simple procedure called multiple access. The method was improved with an addition of a procedure that forces the station to sense the medium before transmitting, and this was called carrier sense multiple access with collision detection and carrier sense multiple access with collision avoidance. CSMA CD tells the station what to do when a collision is detected. CSMA CA tries to avoid the collision. Aloha, the earliest random access method, was developed at the University of Hawaii in early 1970s. It was designed for a radio or wireless LAN, but it can be used by any shared medium. And there are potential collisions in this arrangement. The medium is shared between the stations. When a station sends data, another station may attempt to do at the same time. The data from two stations collide and become garbled. Now let's see pure Aloha. What does mean by pure Aloha? In this diagram, the original Aloha protocol is called pure Aloha. This is simple but elegant protocol. The idea is that each station sends a frame whenever it has a frame to send. However, since there is only one channel to share, there is a possibility of collision between frames from different stations. There are 4 stations that contend with one another for access to the shared channel. These stations, for example, in this diagram, each station sends 2 frames, right? So there are total of 8 frames on the shared medium. Some of these frames collide because multiple frames are in contention for the shared channel. And now the 2 frames will survive. That is frame 1.1 from station 1 and frame 3.2 from station 3. We need to mention that even if one bit of a frame coexists on the channel with one bit from another frame, there is a collision and both will be destroyed. It is obvious that, once again,